In 2.3, you are going to have to tell the difference between linear functions and nonlinear functions. Let me write that down real quick. Linear functions. Linear functions. What is it that I know about linear functions? How do I know if something is linear? Let's talk about its graph first.
If it's a straight line.
If it is a straight line, it's a linear function. If it is a straight line, it is a linear function. Let me give you some examples. If the graph looks like this, it's a linear function. If the graph looks like this, it's a linear function. It doesn't matter if it's increasing or decreasing. It doesn't matter if it's continuous, which means solid, or if it's discrete, which means dotted. It's a linear function. There are others that are nonlinear functions. Nonlinear functions. Let me give you some examples of a nonlinear function. First off, a nonlinear function is not a straight line. Nonlinear functions are not a straight line. So, for example, nonlinear functions can be exponential. They can be quadratic. They can be absolute value. They can be piecewise functions. And so I want you to remember what that looks like. Exponential graphs are graphs that go and either get exponentially bigger or exponentially smaller. Quadratic functions make these U-shaped graphs. Absolute value functions make these V-shaped graphs, either upwards or downwards. And piecewise functions are when we have pieces of two functions that are put together. So we have linear functions. If it's a straight line, it's a linear function. It can be increasing, it could be decreasing, it could be constant. I'll even draw in a constant example right here. We have nonlinear functions, which are not a straight line, like exponential, quadratic, absolute value, or piecewise functions. And your job will be to tell the two apart. 2.2 and 2.3 look almost exactly the same. Blake?
For the nonlinear function, it also could be straight up and down.
Yes, that's true. A nonlinear function could be a vertical line, because that's not a function as well. Perfect. Well, actually, I take that back. It says nonlinear functions. So it's not a function. We would not describe a vertical line as a nonlinear function. We would describe that as not a function. Does that make sense? These ones can be functions without being, and they're nonlinear. These are functions and nonlinear. A vertical line is not a function at all. Let's go with that. That's what I want to make sure I clarify that for you. Okay, let's do example, and this will be like number 1 on your worksheet. We have hours, and we have wages. Hours and wages. And I'm going to make a table for you, like this. And I'm going to do 2 hours, and 4 hours, and 6 hours, and 8 hours, and 10 hours. And the wages will be 20, and 40, and 60, and 80, and 100. The first thing that you will be asked to do is to graph whatever information they're going to be asking you to do. So if I were to graph this particular equation, as I told you before, what's important is to use your common sense. Common sense says, first off, which one is going to be my x-axis? Which one's going to be my independent variable? X-axis independent. Do you know? I'm going to call this one my independent variable. It's my x-axis. Why? Because do hours depend on wages, or do wages depend on hours? How much you make depend on how many hours you work, or how many hours you work depends on how much you make? Dependent is always your y-axis. So I say that to you because you need to hear it again and again and again. Hours for us should be on the x-axis, and our wages should be on our y-axis when we go to graph. And when I go, that's what my axis is labeled as. Now I'm going to do the scale. When I make my scale, I should do something that makes sense. What should I count by for my x-axis? Well, don't forget what this is. This is hours, Jur. Do I want to get to 20? Nope. Riley. So, I have 2, 4, 6, 8, 10. Because I want to count by 2s since the hours go by 2s. Let's do wages. 1, 2, 3, 4, 5. I have 5 of them. What am I going to count by? What makes sense to you to count by? That's where the common sense needs to come in. Count by 20s. I want you to think, what should I count by that's going to make this easy on me? And then, let's plot some points. 220. 440, 660, 880, and 100. Now I made this discrete, but let's think about wages. Can I get paid for 7 hours?
Yes.
Can I get paid for 7.5 hours?
Yes.
If you think about it in like that, then we should make this continuous, shouldn't we? There we go. I should make this continuous because of that. Chase, sign out. Make sure you put your time. Chase, sign out. It's fine.
Hey, yo, Chase.
I'll get him when he gets back. So here we go. We have graphed it. This is the right graph. Notice that I have this labeled. I have that labeled. I have the scale labeled. That makes sense. And I have made it either continuous or discrete. That's what I'm going to expect you to do. The second thing that you're going to have to do is to write an equation for your particular graph. If it is linear, you are going to follow the same idea as what we did in 2.2. Is this linear, first off? Good. We're going to write an equation for it. But I don't want you to use y and x. I want you to use variables that make sense in this situation. What should we use for wages? Agreed. What should we use for hours?
H.
So I want you to write this in terms of W and H. And you told me that wages depend on hours, so I should have a W is equal to something. Wages are going to depend on something. Wages are going to be equal to something. And I'm hoping you know, since this is linear, let me underline that, since it's linear, I know that it's going to be something with change per hour plus something where it begins, or where would it be before? Where would it be at 0? Now, when we decide the change, if you're not counting by ones, you need to make sure you know that. Meaning, here, how much is it changing by? It's changing by 20 for every, how many hours?
2.
For every 2 hours. It's changing $20 every 2 hours. So when we are thinking about change, I always want this per 1 unit. I need it in single units. It's not $20 it's changing by. It's 20 every 2 hours. So how much is that per hour, basically? $10 per hour. And I'm hoping that kind of makes sense to you, because that's what you're going to use for your rule or your equation. Remember, I could say those interchangeably. Where is this when it would be 0? What would the wages be if you work 0 hours? I'm curious. I don't have to put plus 0 in the equation, but I want you to know when it's linear, you have the two parts, the change and the before, or where it begins. And it begins at 0. For this kind of job, you don't get any wages unless you work. And then there are some jobs where you get wages and you haven't even worked yet. That's a weird one. Let me give you an idea of a mechanic. If I take my car to a mechanic and I say, you know what, my car's kind of going, right? They are going to tell me, well, $75 for us to look at it, and it depends on what is wrong before we tell you what the final price is. Oh, that's why it's very helpful for me to know why my car might make those sounds or what goes wrong, because otherwise I have to trust the other person who is going to charge me $75 to look at it, plus the parts, plus the labor to fix whatever it is that's causing my car to do that. There are jobs like that. That's how come mechanics, if you want to become a mechanic, I would strongly recommend it. They make a lot of good money. Just telling you, there's nothing wrong with being a mechanic. All right, with that being said, we have this. That's our equation. Let me mention 2 more things, and then you will be done with your notes. Nonlinear equations. Let me scroll that up a little. Sometimes on this worksheet, you're going to have a nonlinear equation. Let me show you an example. Here's x, here's y. I'm going to write my numbers as 0, 1, 2, and 3. That looks pretty good. And then I'm going to have 1, 2, 4, and 8. It's all right. You can pick it up. I'm going to graph this real quick for you. Let's say I have this table, and your table is going to say, let's graph it. What should I count by over here? What should I count by? Ones. I'm going to put 0, 1, 2, 3. 0 should be right at the axis. This is my x-axis. Let me label that so I know what I'm doing. And my y-axis. What should I count by?
2.
Now I have to get to 8. 2, 4, 6, 8. Whatever you do, don't go 1, 2, 4, 8. What you want to do is count by the same increments every time. This is a proper scale. Don't assume that you're going to put 1, 2, 4, and 8 there, okay? You want this to be nice and evenly spaced. That's the only way to tell a graph is linear or nonlinear, is if you do this correctly. So now, 0, 1, the x is 0, the y is 1, dot. The x is 1, the y is 2, dot. The x is 2, the y is 4. The x is 2, the y is 4, dot. See, because this kind of looks linear. Let me see. Well, let's go 3 and 8. 3 and 8. Now, if you do your scale correctly, because we will have graph paper on your worksheet, can I draw a line through all these points? What this line actually is a curved line. Is this linear or nonlinear?
Nonlinear.
This is nonlinear. If they ask you to write an equation that is nonlinear, you are going to have to guess the equation. And this is where it gets difficult. If I look at this graph and it's curved, I'm going to have to make a decision way back over here and go, well, it's not piecewise, it's not absolute value, it's probably either exponential, which looks like this, y equals 2 to the x, or it's quadratic, y equals x squared. It's got to be like one of these two types. And that's why in Unit 0, we taught you these equations and their graphs, so that when we get to this kind of stuff, we would have a small guessing clue as to what was happening. This is either this graph or half of this graph. It's got to be one or the other. I don't know if it's this one or if it's this one. Let me see. Does it look like I'm squaring something? I didn't get to 9. 3 squared is not 9. No. 2 squared is 4. 1 squared doesn't. Okay, so I don't think this is quadratic. I think it's exponential. Let me guess. What if I did 2 to the x power? Let's check that one. 2 to the 0. 2 to the first. 2 to the second, 2 to the third. Let's see if I remember. What is 2 to the 0 power?
1.
If x is 0, then y would equal 1. If x is 1, 2 to the first, y is equal to 2. 2 to the second, y is equal to 4. 2 to the third, y is equal to 8. I believe this is the equation for that one right there. So for nonlinear equations, most likely they are going to be either exponential or quadratic. You're going to have to guess the equation. There is no change because the change is different. We'll go into that later on in a future unit.